Hello everyone, my name is Boaz and I want us to look at cells and batteries. Now, a cell converts chemical energy to electrical energy. For the case of a battery, if you connect several cells together, then you come up with a battery. Now, this is a sample electric cell which has two electrodes. The cathode is made up of carbon and the anode is made up of zinc, and here we are going to use sulfuric acid as our electrolyte. So this is a simple electric cell. This is how it looks like. Now let us look at the electromotive force of a battery or a cell. Now the voltage that is provided by a battery when there is no external current flowing is what we call the EMF of that cell. Now, most of the time, the EMF is affected by the internal resistance of the battery itself. So when you measure directly on the terminals of the battery, you obtain the EMF E. But that EMF sometimes is not equal to the internal voltage of the battery. So this is how you measure the EMF of the cell. Now I want us to look at how to determine the internal resistance of a given cell or a battery. So from the first diagram, we are going to connect a voltmeter directly on the terminals of the battery. We are assuming that this battery has an internal resistance R, small r, that is. In the second diagram, we are going to connect a voltmeter on the terminals of this battery, but we will include an external resistance R. So we are going to measure the voltage across R, which is going to be our load in this case. Now the EMF of the battery will be obtained by connecting a voltmeter directly, as I said. So you record down that value, let's say it is E, and then we introduce the external resistance R. When we introduce the external resistance R, it means that current I is going to be established. Now, if current is going to be established, then that means that the potential difference across our load, which is R, is going to be given by the product of current and resistance, meaning V, which is the potential difference across R, is going to be equal to IR. Now, due to the internal resistance, of course, small r, of which we say that it is inside the battery, it means that the EMF E, which we had measured earlier on, will have a value slightly bigger than the potential difference of the cell V after introducing external load. This means that V, which is the potential difference after including the external load, is going to be given by the EMF of the battery minus the voltage drop due to the internal resistance. And the voltage drop due to the internal resistance is going to be given by current which has been established after connecting the external resistance I multiplied by the internal resistance R. Now, if we make IR the subject of this equation, we are going to have IR being equal to the EMF subtract the potential difference across the cell V. Now, we both know that I from Ohm's law is given by voltage divided by resistance, and therefore if we substitute in this equation, we are going to find that the internal resistance R of this cell is going to be given by the EMF E minus the potential difference across the external resistance V multiplied by the external resistance R divided by V, which is the potential difference. Now, since every value here is known, we have measured the EMF, we have measured the potential difference V after connecting R. That means that we can easily obtain the internal resistance of a cell. Thank you for watching. My name is Boaz. Blessed.